In this video, we're going to talk about interpreting graphs. Being able to read a graph in Algebra 1 is incredibly important because it helps us understand the story of what's going on in our function or in our graph or in our equation, whatever it is that we're talking about. So in this graph, it shows each person's height versus their shoe size. The important thing to note first is which axis is represented by which value. So we know in this case our x-axis is represented by height. So the further you go to the right, the taller the person is. The y-axis in this graph is representing shoe size. So again, the higher you go, the bigger their shoe size. So understanding that piece is really important. So the further to the right you are, the taller you are. The further up you are, the bigger shoe size you have. So if I'm looking at this, it says, who is the tallest person, and explain how you know. Well, since I'm talking about their height, I'm looking at the x-axis. So the tallest people we know are over here. So I'm looking to see which person is furthest to the right. When I do that, we keep going, she's still further to the right. Miss Gabriel, it looks like, is the furthest to the right. So she would be the tallest person because her dot is furthest right, which is the tallest. Who has the smallest shoe size? Okay, so shoe size means I'm looking at my y-axis, and the higher we go, the bigger their shoe size. So the lower we go, the smaller their shoe size. If I compare each of these dots to the y-axis, the lowest person is Miss Newton. So Miss Newton is the person who has the smallest shoe size because she's the lowest person on the graph. And since I'm talking about the y values, I'm looking for lowest to highest. It says two people have the same shoe size. Of those two, who is shorter, and explain how you know. So if they have the same shoe size, that means they're at the same spot on this axis. So Miss Sambo is the only one up here. Mrs. D is the only one right here. Mrs. Gabriel and Miss Keys, though, look like they're at the same level on the shoe size axis. So we know that they have the same shoe size. But they also want to know who of those two people is shorter. So the same size we're now comparing is Mrs. Keys and Mrs. Gabriel. Well, if I want to know of those two people who's shorter, that means I want to be furthest left on the height axis because the shorter people are over here. So when I'm looking at each of these, Miss Keys is further to the left, so Mrs. Keys of both of those two people is shorter. So do you see how what we're doing is we're really just comparing it to this axis that we're referring back to over and over again. So let's take a look at example of something like this. We do a lot of these graphs in Algebra 1 where it represents something like distance and time. Now this one's showing the distance of a person from a motion detector. So something it's kind of nice to see is it looks like the person starts, so at 0 seconds, the person is 2 feet away from the motion detector. That's where they're starting. So we should be able to look at this and say, okay, as time goes on, their distance is decreasing. They're getting closer to the motion detector until here, and then their distance is increasing over time, and then it looks like it doesn't do anything. So how far away from the motion detector is the person at 4 seconds? Well, 4 seconds would be right here on my x-axis. So if I want to know where their height is, here's the point on the graph. So it looks like, their distance. It looks like they are 1 foot away from the motion detector. Then they want to know, when is the person 2 feet away? Okay, well, that's a distance. So I'm going to go to where 2 is on my distance, and I'm going to find all of the spots on my graph. Well, it looks like right there. So that's at 0 seconds. So at 0 seconds, they're 2 feet away. And let's see, where else? If I keep scooting over, I might run into my graph again, so I have to look for that. I run into my graph again here, which is at 5 seconds. So the person is 2 feet away from the motion detector at both 0 seconds and at 5 seconds. Now they want us to say what happens between 6 and 8 seconds. Well, at 6 seconds, which is right here on my x-axis, the person is 3 feet away. At 8 seconds right here, the person is still 3 feet away. So if 2 seconds have passed and I haven't changed distance, that means the person is standing still. Their distance is not changing. So that's just a little glimpse into how we might use or interpret or read graphs, but it is a skill that you'll definitely want to practice before starting Algebra 1.